Welcome to the second session of the Enterprise Service Management track. With Paul Yates, and he will provide you the latest and greatest news about secure discovery and dependency mapping, our, let's say, Matrix42 GPS to your IT landscape. A little housekeeping up front. You're all currently muted. You will as well receive the recording of the session afterwards, so it will be made available. Whenever you do have questions, just please note them down. We will have at the end of the day at 3 p.m. Central European time, there is the community track where all of the product management guys and ladies are in one room. You can ask us questions, so please keep the questions with you and ask us later on in that session. That's it already from my end. We'll go and hand over, and Paul, stage is yours. So Paul, you're currently muted, it seems.
Thank you, Klaus. Hopefully you can hear me now. Yes, so welcome everybody to this presentation on the SDDM software. My name is Paul Yates, and I am the Senior Technical Consultant, formerly with FireScope, but now obviously with Matrix, having post the merger. I've been implementing SDDM for over 5 years now, so I was around when it was first designed and implemented. So hopefully I can give you a good in-depth knowledge, and then if we have questions in the session later on this afternoon, be more than happy to take any of those questions on any element of the software and hopefully be able to answer them for you. So I'm going to give you a pretty quick introduction into the software. Basically, I'm going to give you an overview of the software, and then I'm going to go through some use cases just to give you an example of what the software does and why it does it. So the overview, basically, what SDDM is going to do is establish exactly what's on your network. You're going to go out and find every digital asset on your network, everything that's got an IP address. We're going to then understand the relationships between all of those assets. We're then going to understand how those relationships, how those assets support your critical business services. And all of this data can then be sent across to a CMDB, to an ITSM solution, to give you the ability to build a CMDB from scratch without any manual intervention, to be able to make risk assessments on what changes you want to make, and also to understand how your services work, so that you can then look at the situations of maybe doing data center migrations or cloud migrations. So as an introduction, we like to start with this, which we refer to as our service asset maturity model. So what this is we're obviously working in the world of ITIL. We are looking at business processes. We looked at the ITIL maturity model for businesses, which takes a business from being a secure, a chaotic organization through to a fully procedurally driven, documented, process-driven company. And we realized that you really need the same sort of level of information about your digital assets. So we created this asset maturity model, which shows you, gives you the ability to understand where you are, what you know about your assets, and hopefully we can then take you along the journey from not really understanding what everything does to how it sits together and how it supports your critical business services. The faded out elements there, levels 3 and 4, is to move you on to the next part of the product, which is all about monitoring. So we say, you know, how can you monitor your business services if you don't understand them? So let's take you through the journey of understanding those services to the point where you can monitor them, and then you can get things like you can SLAs and forward planning and capacity planning, and all those good things can be put in place. So how do we do it? Well, this is a brief introduction into our architecture. We are primarily a cloud-based software. However, if you do have problems with the cloud, we can take the cloud and bring it back into your premise. So it's ring-fenced, the data is ring-fenced all inside your environment. But the cloud is the preferred option because it lets us do the updates and the support very much easier. On the left-hand side here, we're representing the various components of your environment. So a typical environment, you'll have one or more data centers, one or more cloud environments, one or more remote sites, one or more customer sites even. And the point I'm trying to make here is it doesn't matter what those environments are. The solution is the same across all of them. We will look to bring in an edge device, a simple device which acts as a collector which will collect things like net flow traffic and do active discoveries and can gather data about your network and your infrastructure and all of the assets within it. All of that information is then sent to the cloud for processing, the end result being that in that cloud environment, you have a single pane of glass across your entire estate. We can show you everything in one place. The other abilities that being in the cloud gives us is the ability to send that data across to an ITSM solution, to populate your CMDB, to send the ITSM solution all of the relationships that you can make those critical risk analysis. We can also send our data to a data mart database so that you can have a documented, fully relational database to do all the reporting against, should you wish to do any reporting about the data we gather. And then finally, we also have the ability to send alerts and notifications, and later on I'll explain why we need to do that. So just remember that we have that ability, and you'll see why shortly. So let's move on to the use cases themselves then, because this is the best way of understanding the software. So the first use case is, let's help you know what you don't know. So the situation is, do you understand everything that's on your network? Or do you have something you thought you switched off 2 years ago that is still there? And this is actually very common. It is not unusual to do an implementation for the customer to point at a CI and go, that's not supposed to be there anymore. And we're able to show you it absolutely is. So we're going to help you know what you don't know, show you everything on your network. So how do we do this? We deploy our edge device, we configure the network devices, the switches, the routers, and the virtual routers to send us things like NetFlow, SFlow, any sort of network traffic. And from that network traffic, we're able to understand every piece of equipment that is out on your network. And this is a passive, persistent discovery. This differs from all the other discoveries in all those active discoveries where you go out every hour, every day, whatever, and go and look to see what's on the network. This is continuous and real time. We're consuming that traffic, and from it we can identify any communication that occurs between any CIs. So that's all we need to do to start building up that picture that I showed you a second ago on the previous screen. We'll build up a picture of everything that's on your network. We'll understand every CI out there, so we will help you know what you don't know. So the second case then is, how can we help you automatically and accurately populate the CMDB? Well, we've already gone out and we've discovered what's on your network. We've understood what's on your network by looking at all the network traffic. Now let's reach out to those devices and find out something about them. So this is where we switch into our active discoveries, where we'll reach out and we'll gather some data. And there's a screenshot there that shows you a little bit. I'll explain a bit more in a minute. So how do we do this? Well, we've already built on collecting the network traffic. Now we're going to configure a bunch of discovery jobs. These are active jobs, and I will tell you how they reach out. They can reach out using multiple different methods for gathering data. We can reach out using SNMP, WMI, SSH, APIs, using agents if necessary, talking to your virtual hypervisor. It really doesn't matter what method we have. It's whatever method that you're comfortable with us using and gets the data that you require. Those discovery jobs will go and run at periodic times to gather data about all the CIs, and that's the data we want to bring across to the CMDB. As you see there, we can then synchronize that to the CMDB, and this is about removing the manual processes in filling your CMDB up, and you end up with an accurate and automatically populated CMDB that is also maintained in real time. This is the sort of information we can typically gather. So this is just a simple Windows server. We can get the make, the model, the MAC address, the operating system, etc. The basic information you'd expect to find out about an asset to put into a CMDB. But what if you've got some requirements which are slightly above and beyond that, something a little more different? Well, that's absolutely not a problem. Here I have a customer who also wanted to know the types of CPU on a server, the CPU number of CPUs, and the speed of the CPU. So we're able to use our attribute data collection methods to get that information, and then we can add them into custom inventory fields. Those custom inventory fields are unlimited, and they are available to be synchronized across to the CMDB. So we can take that data and send it and populate anything you like. So as long as we've got the ability to get the data from the machine, we can put it into a custom field and we can send it across to the CMDB. So that's the second case, that's populating the CMDB for you. So the third case is providing you with informed risk analysis for change management. So wouldn't it be nice if you knew how everything relied on each other and how they support your critical business services? With that information, you can make those critical decisions. If I make a change to this CI, what am I going to impact? And this is exactly what we're going to provide you, is a map of interdependencies and service relationships. So again, we're building on what we've done before. We've already put the edge in, we're already running the discovery jobs. Now we've got this mechanism of building service maps. And once we've got those service maps built, we're able to understand the relationships for our assets and make those informed risk analysis decisions. I said previously that we collect the network traffic to understand, and this is the core piece of our service mapping. What we're collecting when we're doing network traffic gathering is we're just collecting header information. We're literally collecting what we call our phone bill. This is who spoke to who, on what port, how often, and how much data. And because we're doing this continuously and in real time, we can very, very quickly build up a picture of what's going on in the network. So for example, we will see a burst of activity on one server that will cause a burst of activity on a couple of other servers, which in turn will cause a burst of activity maybe through other servers. And we will see this over and over and over again, tens, hundreds, even thousands of times an hour. And because of that, we're able to build up a picture, say, this must be a critical business service. This must be something that people are doing time and time again. Not only are we able to build up that picture, but we're also able to build up a picture that says, well, we see the same thing happening time and time again, starting at this server. So we see things hitting the first server, which triggers this pattern. So we're also able to identify what we call service entry points. And the service entry point literally is, what is the start of a service? So when we work with you to actually start building services, we will say, what's the first service you want to build? We will then come to the service entry screen. This is automatically built, and we'll look down this system. We should find the starting point of your service. As you can see from this top entry here, we're fairly confident this is quite an important business service because I've seen 1,200 clients connect to this to trigger off at what we think might be this business service. So we'd come down here and we'd find the thing that you're looking to map. We tick the box on the left-hand side and we hit the grey button to give it a service name, and we let the system go and build the map. And what it actually builds is literally that. It is a map. It is a map showing all of the server-to-server communications, and as shown here, we also talk to your load balancers to understand how your load balancers are configured, because you'll have traffic hitting a virtual IP and going out to one or more members of that cluster. And we need to understand that traffic as well to be able to follow the patterns through the whole environment. So we're showing these clusters as condensed boxes to save screen space. But the key here is everything on this screen is built purely from network traffic. We're able to understand all these communications. This is a service that happens. These interdependencies happen. Now, when we build the first one of these, it will not look like this. It will look a lot more complicated. And that's because by design, we leave nothing out. We will show you everything that has spoken to this service. So you will also see things like antivirus, backups, Active Directory traffic. And what we do is we work with you then to work out which bits you already understand and can remove. So you understand your antivirus. Should it be part of this service? Well, I'm going to suggest that probably it shouldn't, because antivirus should be a service in its own right. So let's remove all those antivirus components, getting down to a bit more of a focused position on the service we're looking for. Active Directory, should that be part of this? Again, that should be a service in its own right, in my opinion. So let's take it off here and take it away. So we take those services that we understand, that we recognize away, which means what you're left with is the key pieces that you want to see and anything you don't understand. And it's those anythings you don't understand that you then need to go and validate and verify, because they may be a critical part of this service that you didn't know about. For example, one of my customers, they went through this process and they were left with one machine they didn't recognize. And they went and looked at it and they still couldn't understand what it was doing. So in the end, they were going to leave it out of their service. Fortunately, they had somebody come back off holiday, and this person was the one person who knew what that box was. and it turned out to be the jump box for their support company. So this service was absolutely critically dependent on that machine, but that machine wasn't being used very often because the support company didn't have to dial in very often, so not many people knew about it. If they had taken that machine away for whatever reason, if they were doing a migration or something, the service would have still worked. But the minute they got their first failure, their support company would have tried to call in and not been able to do so. So that highlights how inactive machines or very little active machines are still critical, and you need to understand how they work on these services. So we will see those activities, we will show you them, we won't exclude anything by default. So you must then go and validate and verify what it is that they do. So you go through that process and you build up the picture of what this service looks like. And what you're doing is you're building a list of exclusions. We're going to exclude the Active Directory, we're going to exclude antivirus. When you come to do your second service, then you start by having all those exclusions added in, which means that when you get to your second service, you've already done most of the hard work. You're left with just, again, the critical components of the service, plus maybe one or two things you don't see. So the first service takes a little while, the rest are very much quicker because you've already done the work of establishing the bits you already know. So after we've established exactly what should be there as the first part of the service, we'll then add in one of our active discovery layers, which is the virtual layer. And this is where we're now looking at the relationships between your guests and your hosts, because these are also critical relationships. You need to understand when you're doing risk analysis, if I change this host, what guests might I impact, and therefore what services might I impact? So we will show you that picture. We'll integrate into your hypervisor, and we'll get that data out of the hypervisor itself. On the right-hand side, you can also see we've got some virtual storage. That virtual storage is again a critical component of this service, because if you make a change to that, you could make a change to the guests, to the hosts, which in turn changes the guests, which in turn impacts the service. So you've now got the bigger picture. You now understand the physical server relationships, the actual application layer relationships, and now the virtual layer relationships. And there's one more layer. We can add another layer of information in. And this is where we put in the network switches. So we'll interrogate your network switches to work out how they all talk to each other. And then we'll overlay that on this infrastructure as well. So because network equipment talks to everything and it gets, there's a lot of going on here, all those green lines, they get a bit busy. But the bottom line is now what you have on that screen is every networked CI that is a critical component of this service. You now understand that if I want to do anything to any of these CIs, I've got to consider all of the things it talks to and all of the services it supports. So we've built up that risk analysis information. Once you get to this position, though, you have the ability to baseline it. And what a baseline means is you're drawing a line in the sand to say, I've gone through this process, I've mapped my business service. This is accurately what my service looks like and what I want my service to look like from now on. That's the data you then send across to your CMDB, because your CMDB now has your complete map of your entire service. So you have all the data in your ITSM solution to be able to say, I understand how everything talks to everywhere else. I can look at it and I can make those informed change management decisions. Now, because we are doing this still in real time, we've built this baseline, but we're still looking at the traffic. We're still doing our active discoveries. We are still able to compare how the service looks at any moment in time to what you've now told us is the baseline. And we're looking for anything that deviates. So if we see a server stop talking, for example, or a new port come online, or a new piece of equipment come online, that is a change to the service. And we will have the ability now to send you that information in the form of alert. If you remember in the architecture diagram, I said we have the ability to send alerts and notifications. Well, that's exactly what we use it for. We can say, you told us that this service should look like this. And actually now I've detected a deviation. I've detected that something has changed and you need to investigate. Now, it could be one of a few things here. The first thing could be that this is part of a managed change. You've gone through the change control process in your ITSM solution, you've done all the planning, all the risk analysis, you've scheduled the change, and actually now you've physically gone and made it. And all that's happening is we're saying, we've just seen that change and giving you confirmation that the change you said you're going to make has actually been seen. Now, that's absolutely fine. You come into our software and you accept the change, you re-baseline, say, yeah, I've changed my service, you've told me you've seen the change, and now that is how it should look. Re-baseline it, resynchronize it, and that completes the change management cycle. You've done everything through raise it, validate it, check the risks, make the change, see it happen, close it down in our side, resynchronize across, we're back in a balanced, managed, change controlled situation. The other side to that coin is you get an alert from us and you're not in a managed change. Well, what that means is you've just had an unmanaged change. Now, that unmanaged change could be as simple as a failure of a piece of equipment. Well, that's fine. Your monitoring tools have probably also told you about this, but at least you're aware of it. You can go and make the change, fix it. If it comes back up, we'll see that change as well. It'll put us back into sync. Everything's good. What if it's not a failure of a piece of equipment, though? What if somebody has made a change that they shouldn't have done? Somebody has made an unmanaged change. Hopefully that is something that was supposed to happen and they meant to make the change request later, or it was an emergency thing. That's fine. You can either fix it by undoing the change if that's the thing to do, or come and raise the change retrospectively, as long as you get the two sides back into balance through some mechanism. But there is one more situation. What if you've had a notification from us of a change and nobody else has made it? Maybe somebody's doing something maliciously. Maybe somebody's powered up a machine, connected it to your network, and they're trying to grab data out of your database. Well, again, because it's changed to the service, we will see it and we can alert you. So we can raise an alert to say, this has changed and you need to go and investigate it. And if you find that it is something that's malicious, at least you've had that very, very early warning about it. Whereas previously you might not have known if somebody had done anything like that. So this ability to gather all this information, synchronize it across to the ITSM solution, not only gives you the ability to do the risk analysis, but it also gives you the extra capability of understanding if something changes, what has changed, and then go and investigate. So one last case then. What if you're into doing data center migrations or cloud migrations? Clearly building your services, building your business services, understanding your business services is absolutely critical to be able to make that those moves. But we need to look a little bit further than the data we've gathered so far. So we've taken you from not understanding what's on your network to actually knowing everything on your network, to understanding how those things then talk to each other, to understanding how they support your critical business services. But there's another layer above that. And that's where a piece of equipment supports multiple services. So as an example, you've got a database server. You typically wouldn't have that database server just work for one service. It's an expensive resource. Why wouldn't you use it for more than one service? So it might support 3, 4, 5 different business services. The same physical piece of equipment is servicing databases for all of those. So you need to understand that I now know that this database server works for my first service, but if it also works for the second one and the third one and the fourth one, how can I make the decisions if I want to move some of this equipment about? And that's what we're going to do. We're going to build you a risk analysis dashboard. So how do we do this? Well, you've done all the work. You're already doing it. Because you've built the business systems, the business maps, the minute you build the second map, we're able to tell if there's any cross dependencies, and we automatically populate this risk analysis dashboard. So we can look at this risk analysis dashboard and we can immediately see which services are have cross dependencies and which don't. So if we take a look at the claims processing service, which is highlighted here, this service has equipment within it that also supports 4 other business services that we've mapped. So what that means is, if I pick up all of the equipment that supports my claims processing service and I move it to the cloud and I remove it from my current environment, I will break 4 other business services. So at least I now understand that, but I need to know what they are. So we can drill into this and we can see these are the business services that are also dependent upon equipment in my service. And this is the equipment that we are talking about. So we can now see these are the servers that are shared across these multiple business services. Now, the question is, what can you do about it? Well, the answer is very simple. You've got a couple of options. You could either consider moving all of these services at the same time because they've all got critical shared dependencies, or you have to look at de-risking these servers, isolating them away from these existing services so that they only support the service you want to move. It's a difficult decision. It's a decision you have to make within the company, but at least you have all that information to hand to be able to make those decisions. And this information isn't just shown on this display, it's also shown on the maps. If you select a single CI, it'll show you all of its CI to CI relationships, and it'll show you all its service dependencies. And all that information is also sent across to the CMDB, so you can see that data in the ITSM solution as well. That is a very, very brief introduction into SDDM and how it functions. And if you have any further questions, now is the time for me to take them. And I'm just looking.
Actually, thanks, Paul, for that great introduction to SDDM. As already stated, we will run the Q&A session at the end of the day, starting at 3 p.m. In order to save you the time as well, get a little bio break, get a new coffee refill. Up next is Silke with the IBM compliance, so it's starting 1:30 sharp. Thanks again for Paul for the nice presentation, and for all of you for attending, and looking forward to meet you in the other slots and latest in our community track session at the end of the day.